Okay, synthetic division. So we've been dividing with long division, which you can use 100% of the time. It will always work. Synthetic division is just a shortcut to dividing. But it only works when you're dividing by a linear binomial with a coefficient of 1. Okay, so if we have these 5 different examples here, that first one I can use synthetic division on because it's just an x there. The second one I cannot because it's a 3x. Third one I cannot because it's an x squared. That fourth one I can because it's just an x. Fifth one I can't because it's an x cubed. Okay? So let's divide this using synthetic division. First you draw this like backwards, or not, it's a real L, this L shape here. On the inside are the coefficients, and the outside are the constants. So inside, I'm going to have 1, -1, -27, and -28. And that came from this right here, just those coefficients there. On the outside is the opposite of this sign right there. So that's a +2, which means on the outside, I'm going to have a -2. And then the first step in synthetic division is to draw. I want you to actually draw that arrow every single time. Draw that arrow, bring down our 1. And then we multiply. 1 times -2 is -2. And we put it right underneath the next term. Then you're going to add those. -1 plus -2 is -3. Then you multiply. -3 times -2 is 6. Add those. -27 plus 6 is -21. Multiply, you get 42. Add those, you get 14. Now, that 14 is our remainder. The other numbers are the coefficients to the solution. And you always look at what we started with. That is an x cubed, which means our answer is going to start 1 less. It's going to start at x squared. So that's going to be x squared minus 3x minus 21 plus 14 over x plus 2. And then those are the steps. So the first step is to bring down. Second step is to multiply. Third step is to add. And then fourth step is to repeat all of that. Okay? Let's do another one. So inside, or outside, I have the 2. Sorry. Outside, I have a 2. Inside, 3, -22, 37, -10. Start by bringing down that 3. 3 times 2 is 6. Add those. You get -16. -16 times 2 is -32. Add those, you get 5. 5 times 2 is 10. Add those, you get 0. So this means that there is no remainder. And it started as a cubed, so this is going to be squared. 3x squared minus 16x plus 5. Cool? Let's skip C and D. For this one, we have x cubed minus 49x plus 120 divided by x plus 8. We have to always check for missing powers. Here I don't have an x squared, which means I need to plug in a 0 for where that x squared would be. So this will be -8 on the outside, 1, 0, because that's where the x squared would be, -49 and 120. Then you bring down that 1. 1 times -8 is -8. Add those, you get -8. -8 times -8 is 64. Add those, you get 15. 15 times -8 is -120. Add those, you get 0. So again, there's no remainder. It started as a cubed, so this is going to be squared. X squared minus 8x plus 15. Okay, we're going to skip F. It's kind of the same thing. So now you can use division to factor polynomials. And just say we're given a polynomial function and one of its factors, you can completely factor it by dividing it and then by factoring whatever you end up with. Okay, so if we have x cubed minus 5x squared plus 2x plus 8, and we're dividing that by x minus 4, We're going to use synthetic division here because that's the easiest. So we have 4, and then 1, negative 5, 2, and 8. Bring down that 1. 1 times 4 is 4. Negative 1, negative 4, negative 2, negative 8, 0. So that that divided down to x squared minus x minus 2. Now we can factor this, and that will factor to x minus 2 and x plus 1. And you could just use the x there to factor that, or whatever method you use. So then the completely factored form here would be x minus 4, x minus 2, x plus 1. And we have to include this x minus 4 because that was given to us from the beginning. And then this is also included there. Okay? Now we have to determine the zeros of the function. So I'm going to take my factors and set them equal to 0. So I have x minus 4 equals 0, x minus 2 equals 0, x plus 1 equals 0, which means x equals 4, x equals 2, and x equals negative 1. Oh, sorry. And then we're done. Okay, let's do this one. Change that to 84. That was supposed to be 84, not 85. My bad. So then we don't have an x squared, so we're going to plug in a 0 for where that x squared is. That's going to be 7 on the outside, 1, 0, negative 37, and negative 84. Bring down that 1. 1 times 7 is 7. Add those, you get 7. 7 times 7 is 49. Add those, you get 12. 12 times 7 is 84. Add those, you get 0, which means there's no remainder. So this would be x squared plus 7x plus 12, which factors down to x plus 3 and x plus 4. So then the completely factored form here is x minus 7, x plus 3, x plus 4. We have to find the zeros, so we set each of those equal to 0. Solve them, so that would be x equals 7, x equals negative 3, and x equals negative 4. We're going to save the rest of the examples. I'm not sure if we'll do them in class. We might. But remember to take the quiz, and thank you. Hope you're having a good night. Bye.